Okay, guys, so in this video, we are continuing to look at special cases. And here again, we are looking at the system of two equations and two variables. And it looks like it's, just one of those systems. It doesn't seem like there's anything going on with it. The two equations do not look like they're the same. So we are going to try to solve it by using method of elimination. And we'll see what is so special about it. Well, let's say I just want to eliminate x again. So to eliminate x, I'm looking at the coefficients, right? So this coefficient is 2, this coefficient is 4. So I want to turn them into basically opposite numbers. So one will be, let's say, 4, and the other one is negative 4. So I can achieve that by multiplying the first equation by negative 2. And actually, there's like different methods. For example, you could have actually multiplied this one by negative 4 and that one by 2. But that's not the most efficient way to do it, because if possible, you could just maybe multiply one of them by something, so you have less work. Okay, so when you multiply by negative 2, you want to go ahead and distribute that negative 2 to all terms. So remember to also switch signs when you multiply by a negative. So you get negative 4x, right? Because negative 2 times 2 is negative 4. Then we got negative 2 multiplied by a negative. Well, what does that mean? It's just like multiplying by negative 1, basically. That's a positive 2. So plus 2y. And then equals negative 2 times 1 is negative 2. The second equation will just keep the same. And we're going to try to add them up. Okay, so when we add them up, we see that the x term does cancel, which was the whole purpose of this exercise. So negative 4x and positive 4x goes away. Remember, again, that what you want is the opposite signs and the same value, like absolute value, but opposite signs. You can't have, because it's a typical mistake when people will do 4x plus 4x and then they say that's 0. That's not 0, that's like 8x, right? So you want them opposite signs. Okay, but then guess what happens also over here? 2y and negative 2y also cancel, give you 0. So don't forget to just write 0. So this will be like 0 plus 0 equals, well, what is negative 2 plus 5? Well, that is actually 3. Okay, so 0 plus 0, well, that's 0. And then so we get 0 equals 3. Well, everybody knows that 0 and 3 are not the same, right? So what we have here is a false statement, right? So this cannot happen. 0 is not 3. So what that tells you is that this system is no solution situation. So usually what that means is that the two equations are actually parallel lines. So the first equation is like 2x minus y equal 1. If you solve this for y, you get 2x minus 1, right? So that's the first one. And the second one is going to be, let's say you got 4x minus 2y equals 5. So if I want to solve this for y, I get negative 2y. So subtract 4x from both sides. You get 5 minus 4x. And then you want to divide everything by negative 2. So remember to divide the whole thing. So you get negative 5 halves. Plus 2x. So notice, or you can write it as 2x minus 5 halves. So when you look at these two equations, y equals 2x minus 1, and then y equals 2x minus 5 halves. So you can see that the slopes are the same. So these two lines have the same slope, but the y-intercepts are different. So if you want to compare them, if you want to compare the two lines, one of them has slope of 2 and a y-intercept of negative 1. So let's say this is negative 1. So, and the slope of 2, well, I'm not, I don't want to deal with the scale, something like that, right? And the other one intersects as negative 5 halves. So this would be like negative 2 and, well, somewhere over here. So if you draw a line also with the slope of 2, that's a line that's parallel. So what that means is that these two lines never intersect, and so you have no solution.